Hello, in this lecture we will find the area of the yellow circle. In the picture we have semicircle and the center of the semicircle is at point O, and let's call the center of the yellow circle M. And then let's connect the two centers together. So we connected the center of the circle, we connected the center of the yellow circle that is in point M and the center of the semicircle that is at point O. And now we will connect between point M and point P. As you can see from the picture, point P is a point of contact between the yellow circle to the semicircle. And also we have the second contact between the yellow circle and the semicircle that is at point O, and point O is also the center of the semicircle. Okay, actually we have at the OM we have a theorem that states that the point of contact between two circles creates a straight line between the line that connects their centers. So I will write down the theorem. We'll call it rule number 1. So rule number 1 states that the point of contact between two circles creates a straight line with the line segment that connects together their centers. Again, I will read rule number 1. So rule number 1 states that the point of contact between two circles creates a line, creates a straight line We'll read it again. The point of contact between two circles creates a straight line with the line segments that connects together their centers. Okay, now we'll explain it. The point of contact between the semicircle and the yellow circle is point P, and point P creates, if we connect point P with the line segment that connects between those two centers, the center of the yellow circle is M, at point M, and the center of the semicircle is at point O. And MO is the line segment that connects between the two centers. And if we connect between the point of contact between those two circles to the line segments that connects between those two circles, then PMO will be a straight line. Okay? So, because of the fact that PMO, again I will read it again, the point of contact between two circles, that is to say point P, create a straight line with the line segments that connect together their centers. The line segments that connects the two centers is MO. The center of the yellow circle is at point O, and the center of the semicircle is at point O. Again, the center of the yellow circle is at point M, and the center of the semicircle is at point O, and the line segments that connects between those two centers are MO. And the rule states that PMO is a straight line. Okay? So, actually, MO is the radius of the yellow circle, and also M, because it exits from the center of the yellow circle and ends at the point O, that is a point on the yellow circle. So it is defined as the radius of the yellow circle. I marked it as R, small r, and also MP is the radius of the yellow circle, and because of the fact that PMO is a straight line, we can say that 2 times R is the diameter of the yellow circle. Okay, 2 times R equals to the diameter of the yellow circle. Okay, now because of the fact that PMO is a straight line, and actually O is the center of the semicircle, and we have from the center of the semicircle we have OP that is a straight line. So we have a line that starts from the center of the semicircle and ends at point P, that is also a point that is on the semicircle. So we can define PO as the radius of the semicircle. Let's call it capital R. Okay, OP is capital R, and also OQ will be capital R because it exits from the center of the semicircle and ends at the point that is on the semicircle. So that is also R. And also we have O, actually QO is tangent to the semicircle, and actually QO, the line QO is tangent to the semicircle at point O, or QO is tangent to the radius of the semicircle at point O. And actually we have a theorem that states that in any circle a tangent to a radius, or a tangent to the radius, or in any circle a radius and a tangent to that radius are perpendicular to each other. I will write it down. So this will be rule number 2. In any circle, a tangent or in any circle a radius and the tangent to that radius, are perpendicular to each other. So I will read it again. Rule number 2 states that in any circle a radius and the tangent to that radius and the tangent to that radius are perpendicular to each other. I will read it again. Rule number 2 states that in any circle a radius and the tangent to that radius are perpendicular to each other. Okay, so actually we have here radius MO of the yellow small circle, and we have tangent QO to that radius. So according to rule number 2, the radius and the tangent to that radius are perpendicular to each other. For that reason, angle POQ will be equal to 90 degrees. Because of the fact that in any circle, the radius and the tangent to that radius are perpendicular to each other. So MO is the radius of the yellow circle and QO is the tangent to that radius. For that reason, MO, the radius, is perpendicular to the tangent. That is to say, angle POQ equals to 90 degrees. Okay, so actually I will draw again the right triangle POQ. So angle POQ equals to 90 degrees and PO equals to capital R. PO is the radius of the semicircle, and also, so this point is point O, this point is point P, this point is point O, and this point is point Q. Okay, so PO is the radius of the semicircle because it exits from the center of the semicircle and ends on point P, that is a point on the semicircle. So this is the definition of radius. Any line that exits from the center of the circle and ends on the circle is defined as radius. So OP is the radius of the semicircle, and for the same reason also OQ is the radius of the semicircle because it exits from the center of the semicircle and ends at point Q, that is a point on the circle itself. For that reason is defined as the radius of the circle, of the semicircle, and it is given us that side PQ is equals to 7 times root 2. So we will apply the Pythagorean theorem on this right triangle, that is to say R squared plus R squared equals to 7 root 2 square, and R squared plus R squared equals to 2 times R squared, and 7 root 2 square equals to 94 times 2. 49 times 2. 7 times 2 square equals to 94 times 2. So we have here the equation that 2 times R square equals to 94 times 2. We can divide the equation by 2. Then we will get that 2 is cancelled. R square equals to 7. And R equals to I made a mistake. After we divided the equation by 2, we got that R squared equals to 94. So if R squared equals to 94, then r equals to 7. Okay, so the radius of the semicircle equals to 7 units, but as we can see from the drawing, the relationship between the small radius of the yellow circle to the big radius of the semicircle is actually 2 times r, because we have the conclusion that PMO is on a straight line, so actually it is 2 times r is the diameter of the yellow circle, equals to the diameter of the yellow circle of the yellow circle. So 2 times r also equals to r, capital R. 2 times the radius of the small circle equals to the radius of the semicircle. So actually, if 2 times r equals to r, then small r equals to r divided by 2. So we can, but we found out that r, capital R equals to 7. So small r will be equal to capital R divided by 2. That is equals to 7, because capital R equals to 7 divided by 2. So R equals to 3.5 units. So actually the radius of the yellow circle equals to 3.5 units. And we know that the area of a circle equals to pi times r squared. And r equals to 3.5 units. So the area of the yellow circle will be equal to pi times r squared. R equals to 3.5. So it will be pi times 3.5 squared. And actually the area of the yellow circle will be equal to 12.25 pi. I will check that I'm not mistaken. That's equals to 38.48. Okay, so the area of the yellow circle equals to pi times r squared. R equals to 3.5 units, so r squared is 3.5 squared. 3.5 squared equals to 12.25, and 12.25 equals to 38.48 units. So the answer to the question is that the area of the yellow circle equals to 38.48 units. Okay? Thank you very much.